Hello, welcome to this lecture video. I'm teacher Melay. So in our previous video, we were able to introduce that we actually have different problem-solving heuristics. So namely, search for patterns and formulate conjectures, make a diagram, organize data, and use logic, modify the problem, divide into cases, consider extreme cases, look for symmetry, choose effective notation, work backward, pursue parity, and color and prove. So in this video, we will just focus on the letter A, to search for a pattern and formulate conjectures. So of course, if you are given a problem, the tendency is that you have to analyze the problem first. So in our previous videos also, we were able to discuss the problem solving steps. And of course, it's not that you have to use searching for pattern instantly, but this is the strategy that you think can solve the problem. So in the first step, you were able to analyze the problem. So you read the problem and analyze, and then you make a strategy on how to solve the problem. And one possible way is to search for a pattern. So for example, in this given example, so we have to prove or disprove that a set with n elements has 2 raised to n different subsets. So the conjecture here is that the pattern is the 2 all over n. So for us to determine that if you are given a set, the number of elements is 2 all over n. So we, of course, need to explore. So in doing that, so let us consider an exploration, like for example here. So let's have, what if the number of n, so if our n, for example, is 0, our n is 1, our n is 2, and our n is 3. So we are going to identify if the pattern will result to 2 raised to n. So the elements, what are the elements of, so let us also consider the elements of S. And then, what are the subsets of S? And of course, the number. Okay, so we are going to use this table for us to search for the pattern. So if n is 1, the number of elements is of course empty. So that is null, or we can simply say that it is none. And then the subset is null set or empty set. And we know, of course, that there is a number of, the number of subset of S is 1. And that is, of course, empty. And then for the element, if n is equal to 1, we also know that we can produce a subset x sub 1, where the elements will consist of, subsets will consist of empty, or it will consist the element x sub 1. And the number of subset is, obviously, we have 1 and 2. Okay, if our n is 2, elements of S could be x sub 1, x sub 2, where the subset is empty set, and we can have x sub 1. We can have x sub 2. We can also have x sub 1 and x sub 2 in one subset. So 1, 2, 3, 4, we have actually 4 number of subsets of S if n is equal to 2. While for n is equal to 3, so let's have x sub 1, x sub 2, and x sub 3. So we have the empty set, the subset of S, and then we have x sub 1, x sub 2, a set with x sub 3, a set with x sub 1 and x sub 2, a set with x sub 1 and x sub 3, a set with x sub 2 and x sub 3, 1, 2, 1, 3, 2, 3, a set with x sub 1, x sub 2, and x sub 3 together. So we have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 number of subsets. So if we are going to continue that, so we are going to move to 4, 5, 6. So what do you think will be the next number if we are going to consider also 4? And by analyzing this, so we have here a pattern that reveals that this is 2 raised to 0, 2 raised to 1, 2 raised to 2, and 2 raised to 3. Therefore, so we can make a conjecture that the result is 2 raised to n. So this is the example for searching for a pattern and conjecture. So we are going to have another video for the example for other heuristics. Thank you for watching.